Hey folks, I'm Dan, and today I'm going to be talking about a topic that is basically a continuation of the series, and that is exploring the Halo Infinite API. And specifically, I'm going to be talking about the various data formats that are available as API responses. As the responses flow in, as you get that information through the API, there's different ways in which that output can be represented. So that's what I'm going to be diving in today. And I'll be talking about these in an interesting order. So specifically, I'm going to be talking in the order of verbosity. So I'm going to start with the least verbose format, so the one that gives you very little information, to the one that gives you the most. So let's dive in. First of all, I want to start with a format that the game itself uses. So that format is called Bond. So Bond is an open source cross-platform framework, as it is described on the official Microsoft website, but its whole idea is that it enables developers to serialize, or basically encode, large amounts of data in a very, very compact format, so you don't actually have to worry about sending too much information over the wire, which is critically important if you have something like a video game that actually ingests that data and process. You want to make this as fast of a process as possible. So Bond is one format. It carries very little information, and I'll show you later why. The second format that is supported by the Halo Infinite API is JSON, or the JavaScript Object Notation. This format is a little bit more verbose. It includes a little bit more information than Bond, specifically around things like properties, so you know what data you're operating with. And I'll show you again in a demo of how that works. And then lastly, we have XML, which is Extensible Markup Language. And XML data is actually also very helpful to look at because it provides the most information encoded within the output, and we'll see different endpoints that do this. Something I do want to call out is that there are some endpoints within the API surface that support Bond. Almost all of them support JSON, and just a few of them do support XML. So if you're looking at getting the same kind of deserializer, if you're writing any kind of code that uses that, you might not have that same consistency across your entire code base because different endpoints return data in different formats unless it is supported. And we'll talk about that a little bit more. But let's start with Bond. So as I mentioned, Bond is this format that enables you as a developer to encode large amounts of information and package it up in a very compact piece of binary data that you can send over the wire. How does this work inside the game? And so to check this out, I'm gonna minimize my browser window. And what I have here is a tool that you're probably already familiar with because we talked about this in the previous edition of our series, and that is Fiddler. So Fiddler allows me to inspect the network traffic. It is specifically right now targeting the game process, so I'm looking at it, and there's a number of different requests being sent to the Halo API. In this case, there's the game CMS, which is the content management system that fetches a lot of the information about things like challenges and all that awesome stuff that is getting dynamically inserted into the game. But what's interesting here is because I'm talking about the Bond format is where this format is actually used. So let's look at the response. So in this case, I'm looking at progression. There is a file for challenge content, and that is client challenge definitions. So something interesting around the challenges, as I mentioned in the game. Let's look at the response. And for this, I'm going to click to decode because the response is encoded by default. It's, I believe, gzipped, so it's compressed as well. So we want to see that. And then I'm going to click on raw, which is going to show me what the response body or the content actually is. Now, looking at this looks like quite a bit of gibberish. So there's words that you can kind of make out and see that this is called practice makes perfection, and then play any match normal, right? So there's some characters here. It's not really well readable for a person, unlike, if you're reading JSON or XML. So this is Bond, and we can clearly tell that this is Bond because of the header called content type application X Bond compact binary. Now, what this means is that the content that's being passed to us over the pipe is very much in that compressed package, the binary blob, that we cannot easily read by hand. But the game knows this because the game has the schema. we don't. So how do we actually understand what data is passed in this format? So to do this, let's look at the exact same representation, but in JSON format. So what I'm going to do for this is I'm going to show you how I switch to Postman. So I'm going to go to my Postman instance.
This is, without question, my favorite weapon.
And within my Postman instance, I've been doing some explorations with other APIs here. So I'm going to switch back to my collections, but I'll also just jump back real quick to the Fiddler instance that I've been running just now. And I'm going to copy the endpoint here. So I'm just going to copy just URL and I'm going to paste it here. Notice that it's exactly the same URL that I just now had in Fiddler. So I want to see what this data looks like. I'm just going to use the authorization header that I've discussed earlier. So the X343 authorization Spartan. And if you are curious how that token is actually produced, look in the description to see the details. But I have the Spartan token defined. I'm going to be using that. And I'm going to send this request. And notice that as I sent this request, I got by default the JSON representation. What you'll notice is that for a lot of the API calls that are being made inside the Halo Infinite API, the responses are actually JSON by default unless specified otherwise. So that tells us that the game actually explicitly asks for bond encoded responses because, as I mentioned, when you have a game that depends on networking and specifically getting data as fast as possible, you want to get the smallest chunk possible over the wire because performance. So in this case, I am looking at the response that is encoded in JSON. So it's somewhat verbose because I see the difficulty, the normal, category, reward, all the information, threshold for success. It gives me a lot of context as to what I'm looking at. In this case, the challenge definition for one of the dailies that you get in game. But what happens if I try to request something that is, well, let's say not necessarily JSON. Let's request something that is bond encoded. And for this, I'm going to once again go back to Fiddler. Remember how I mentioned that there is this application X bond compact binary header. So what we're going to do is we're going to copy this header here and go back to Postman, to our experimentation tool, and set the accept header. And in this case, the header is going to be set to application X bond compact binary. And in addition to this, we also need to specify another header, which is accept language, because it's required when you're requesting data in bond format. I'm going to set this to EN US. And I'm going to send this request now once again. Now I got the data in bond format, and notice that this is complete gibberish, just like we saw in our previous example in Fiddler. That is by design, because actually a lot of the data is binary encoded, but it's not represented as individual characters. And to do that, we're going to use a tool that I've built that is called Bond Reader. And Bond Reader allows you to parse the content of the response and see what exactly it represents in Bond. So we're going to switch to that tool momentarily. Bond Reader is an open source tool that I've implemented myself to make it easier for me to understand the Bond content. And it's actually based on the library that is built by Microsoft for Bond file parsing. I just wrapped it in a nice CLI that enables me to traverse different file types encoded in Bond and output their structure. So to do this, there's a couple of things that I want to call out here, and that is specifically that every Bond file that exists out there or that is being encoded can be encoded in one of the two versions of the Bond protocol, version 1 or version 2. Now, in our case, we're always going to be working with version 2. So all API responses coming from Halo Infinite are actually encoded in version 2 of the Bond protocol. So that makes it easy. And if you're ever encountering one of those files in the wild, you know exactly which type to use. So to experiment a little bit more, what we did, I took the file from Postman that we saw, that Bond response, and I saved it to a binary file. There is a functionality that is available in Postman, actually, that is called save response. So you can click on save response here, save to a file, and this makes it extremely easy for you to take the content that is completely unmodified, it's untouched, and then pass it to any other tool that you might have. So instead of me just trying to manually parse this file with a hex editor, as I mentioned, the bond reader tool allows me to just parse this automatically. So what I'm going to do is go to my terminal.
Double kill.
Skewer available.
Triple kill. Overkill.
Now let's switch to my other screen. So I'm going to focus on my second monitor, and then you'll see that I've already typed in the command for bond reader, that is br.exe. That is the executable file. You can download this yourself. And I use the parse command. I set version 2. Input is the response file that I saved from Postman, and then output is a test.txt file because all I'm getting out is really a text file. So I'm going to press on enter, and notice that I just now got the exact representation of what's inside the bond file. So I get practice makes perfection. Then it's obviously a string. Then there's a struct. There is an integer, an int32 with a value of 50. Then there is a list that tells me how many items in container. So there is 0. There is actually nothing inside the container. And then there is another integer, a string, play any match, W string, normal, which I'm guessing is a difficulty here, another int32, and then BT stop, which means it's the end. Now, when you look at bond files, what's cool about this is that a lot of the fields that you see, so notice that if I go to Postman, I don't actually see any of that information because it's separated by, specific binary values that are not represented as characters. But when I do go to my terminal, I see all of those using the bond reader tool because it just decodes that binary content as something that is representative of specific expected structures. Bond has a number of those structures, and this way, unlike a JSON or XML representation, when I look at content that is encoded in bond, I never see the properties. So in this case, practice makes perfection. I know the field ID, and I know that it's a wide string or W string, but nothing else. I don't know if this is a description or the name. So when you're looking at bond data, you need to understand what the data actually represents, because you can imagine that in the context where you have 0 information about what this response is, for example, if I did not know that this is a daily challenge, I don't actually know what any of this would represent. This is why it's important for us to go back to Postman here. I'm going to disable the headers that I've just been playing with, and I'm going to send once again. And actually, in this case, I might want to just explicitly say the accept, and I want to do JSON because that's what I want. Let's set it to that, and then I'll get the data.
Spartan. Double kill. Ballista. Ballista.
So I had to do a couple of clicks here, but ultimately, sometimes the API response are cached. So now I'm getting the JSON data here again. And notice that unlike what I see in my terminal here, which is a parsed bond file, if I look at the JSON information, it has actually a lot more content than normally you would expect from a bond response. And I also have explicit properties that define what this is. So in the context of practice makes perfection, if I look at, this is actually a value for a display for title, which status ready. There's a number of translations that are not captured yet. And then there's a category, the difficulty. So all these things, looking at the JSON information, I know what this is that I do not get from a bond response. Now, this makes it very easy for me to then reuse this data somewhere else. So if I'm writing a .NET application or a Python application, I can actually refer to these properties directly because I know what this is. I can say that I want to get response.difficulty, for example, if I have an entity representing the response, instead of me juggling different field IDs or arraying members by index, right? So I say response and then value 0 and sub value 1. So I don't need to do any of that when I'm dealing with something like JSON. Now, also the other format that I called out is XML. In this case, not every endpoint supports it. So you'll run into some of them that support XML, other ones don't. You'll have to experiment with some. I'm still in the process of documenting some of them. But to actually see whether the endpoint does XML or not, all you need to do is actually modify the accept header. So in this case, right now it says application.json. And what I'm going to do is I'm just going to set it to application/XML. And I'm going to send the response. And in this case, it says forbidden for some reason. So I cannot get the XML data, but if I take it back to JSON and then resend the request, I get the data just fine. So in some cases, that is not possible. But let's find an endpoint where this is actually possible to see what that XML data is actually looking like.
Flag capture.
One of these endpoints that supports XML data is actually the match stats endpoint. So I'm going to switch back to my monitor here. Notice that I have another API endpoint here, Halo Stats. This is a different service that tracks of the statistics for your matches or matches of other fellow players on Xbox Live. So in this case, I'm looking at one of the accounts that I've seen in-game before. This is not necessarily, limited to just your account, because through stats, you can see statistics for other players as well. And that is by design. That's public information. In this case, I'm looking at a player match history record for somebody. And notice that one of the things that is different here is that you are looking at XML data. This is all available in a very verbose format. So unlike the JSON content that we saw earlier, we only see properties. Here I see actually the names of the containers. So match history response with all the schemas defined for the XML content, with all the details for all the properties, match info. There's a lot of information. GUIDs, or the globally unique identifiers, are actually encoded as separate values as data 1, data 2, data 3, and data 4. Let's compare this to JSON. So the exact same data for the exact same set of matches. I'm going to do JSON and I'm going to send the request here. Notice how this became a little bit more compact. Now I have GUIDs as a match ID, but I lose the information about the names of the different containers that have existed, right? So I'm looking at match results here, and all this data is very, again, easy to parse, even with just your eye. You can just look at this and understand what this is. If I switch back to XML, it becomes a little bit harder, but you also get insights as to the different match info types. And in some cases, for example, here I have a game variant category that tells me it's multiplayer Fiesta, which is very easy for me to understand what this is. Let's switch to JSON. So remember, this is game variant category. So I'm going to go back to JSON and resend the request. See game variant category. Now I have 9. I have no idea what 9 is. So I actually do need that context. And when I look at XML files, it becomes very easy to me to infer what is this value actually representing. Same with things like lifecycle mode. Looking at this value here that says lifecycle mode value of 3. Not necessarily very explicit what this is. But if I talk about the XML format, let's look back here and it says lifecycle mode, match made. That's a little bit easier to parse, right? So you might need to fiddle with the different APIs to understand what exactly you're getting and how to interpret that data. So this is something to keep in mind. And what I want to also finish this on is call out the sizes of the data pieces that you're getting, right? So I called out from the very beginning that Bond is the most compact, JSON is a little bit more verbose, and then XML is the most verbose. To do this, let's actually compare the sizes of the information that you're returning. So in this case, I'm looking at the exact same endpoint for a player match history. I need to call out that all the data that you will be getting in this case is absolutely identical. It's just represented differently across different formats. So in this case, I'm looking at XML. So it's about 100.45 kilobytes. Not terribly bad, especially in the modern days of fast internet. 100 kilobytes is not anything to really worry about. Let's do this as a JSON request. So I'm going to do this. 25 kilobytes. So it's a little bit less, right, than XML because it's significantly less verbose, as expected. So the size decreased because all of a sudden I lost all the information. Lifecycle mode is no longer the string representing the mode, is just an integer. Now, what happens if I encode this as Bond? In this case, it's X. I believe it was Bond application. Or I'm going to actually look at my previous request here. And one of them where I was using the compact binary value. Okay, X Bond compact binary. So I'm going to be using this. And let's see how big the response is with data encoded in bond. Only 13 kilobytes. And notice that again, as a human being looking at this response, this is all kind of garbage. I have no idea what this is. This does make sense if I pass it through Bond Reader. And by the way, Bond Reader, you can learn more about the tool if you follow the link in the description. But Bond Reader will enable you to get all this data in a bit of a more readable format, if you will. But notice that 13 versus 25 versus 100. So you want to encode your data in Bond when you know what the schema is on the receiving end on how to decode this. Then JSON makes it a little bit easier if you're building things like mobile applications, and XML if you are a human being that just wants to parse it very easily and not spend too much time trying to understand what this is. So on that note, I want to say that all of this data that you just saw here is available in a bit of an even more human readable format if you're using a library like Grunt. So I'm gonna show you this as well very, very briefly. And Grunt is nothing else other than a library that I wrote specifically tailored for .NET developers, but it's coming soon to Python and NPM. So if you're using JavaScript or TypeScript, that's going to be helpful for you as well. And what Grunt does, it's a library that simply wraps a lot of the API endpoints that I talked about, so you don't actually need to worry about, whether it's Bond or JSON or anything else. Here's some of the code. So for example, if I'm looking at the data models I have for Halo Infinite, I want to look at, AI cores. And if I go to the definition here, the data for things like AI core themes is all already captured in very well structured classes that you can just use without parsing the formats directly. So check out the link again if you want to explore this library a little bit more. It's open source, it's free, and always welcoming contributions. But this is it for different data formats that are being exposed through the API. You can use any of them directly from your application. You'll just need to make sure that you know how to decode that data to make it useful. And again, I'll repeat that: Bond, the most compact; JSON, a little bit more verbose; XML, the most verbose. But depending on your scenario, you might use either of those. So there's no necessarily data loss between the formats, short of very specific end.
That was a good kill.
On that note, I'm gonna wrap this up. Thank you so much for watching this. And if you have any questions, do let me know. I'm always happy to talk about Halo API.
Hill control. Double kill. Victory.